In order to understand the concept of EMF, the more and lost volt and external resistor or load, let's take this question. A cell of EMF 12 volts and internal resistance 4 ohms is connected to an external resistor of resistance 2 ohms. Find the current flow. So let's quickly evaluate that. Now, let me sketch the description here. You have a resistor, okay, a cell. This is a cell connected to an external resistor. Okay, so that is basically what it is. So the cell rating, the EMF here is 12 volts. EMF means the voltage that you measure from the cell when it's not supplying current to an external load. You know, whenever you load a cell, the voltage will drop. When the voltage drops, that voltage you measure across the cell when it is connected to a load is called terminal potential difference. But when it's the voltage you measure when the cell is just on its own is called the EMF. And then the external resistor here of resistance 2 ohms. Then internal resistance of the cell, small letter r, they said is 4 ohms, that we should calculate the current flow. Remember, this is a series connection, so the same current will flow through them. So now, EMF, represented by the letter E, is given as what? The voltage drop across the external resistor, denoted by a big letter V, plus the voltage, the voltage drop within the cell itself. That's the internal voltage drop, which is the denoted small letter V, which equals to this voltage across the external resistor is given as the current flow I times the resistance of that external resistor. Then here, since it's still the same current that it will be because it's a series connection, times the internal resistance will give you that. So you now have I outside, big R plus small r will give you what? The EMF or the E. So we have to find what? The current. So if you make current the subject of the formula here, by dividing both sides by R plus, big R plus small r, so you'll be having E divided by big R plus small r. So if you substitute your parameters there, remember your R, big R is 2 ohms and small r is 4 ohms. So if you substitute that, you have 12 divided by 2 plus 4, which equals to 12 divided by 6. 6 cancel is 1, cancel that 2. 2 amps. So the current flow I is what? 2 ampere. Option D. Thank you.